virtual private networks. Now these virtual private networks or the other kind of networks which can be used. Now the good thing about this is we are going to build our own WAN connection. So let's take an example how VPN is going to work, virtual private networks. Now in this what we are doing is, let's say I got a branch office in Hyderabad and I got another branch office in some different location, maybe in Dubai or in Bangalore, like that. Now I want to build a WAN connection and I'm going to run a small branch office, and I cannot go with the lease lines or any line which is given by the service provider. Now using these VPNs, what I can do is I can build my own WAN connection over the existing internet which is already there. Now it can be internet or it can be MPLS or it can be any kind of other WAN connections you can use, but majorly we can still use internet, and every organization connects to internet, so probably we do connect to internet. But now the question is how we are going to build a WAN connection from Hyderabad to Dubai location. Now for that we need to have some registered public IP addresses on both the sites. So we are going to use some registered public IP. So it can be anything based on the region wise. So because in order to build a logical point-to-point logical VPN network between these two, you need some identification, and probably the public IP is a globally unique IP address which identify your virtual private network, and we can have virtually a separate connection which is built, and this is what we call as virtual private networks, building a virtually private network over the existing public infrastructure or the public network which is already there. Now this is one more common popular kind of technology in today's networks again we use. Now the major reason is it is a little bit much cost effective when compared with any of the other kind of WAN connections. But again, it's something we need to build on our own. So we are just taking a WAN connection, purchase some public IPs on both the sides, and you can build your own WAN connection over it. Now we can build multiple as well, like you can have one more VPN from this way to this way, we can have one more, something like that. Now there are some technologies which works based on this kind of implementations, like there is something called generic routing encapsulation, GRE kind of VPNs, which you will be learning in some security kind of implementations. We have something called dynamic multi-point VPNs. They all works in this format. And then, but the major drawback with these two is there is no encryption or there is no security over for your data. So because the virtual private network is built over the existing internet, so probably there is no security here. So which means it's not going to encrypt the information. So if you are sending your information over this, there is no guarantee that your data is secure. So that is one of the major drawback with this one. Now GRE are typically point-to-point connections. We can have just one-to-one connection, but whereas DMVPN supports point-to-multi-point connections. Just like we do in the frame relay, we can have point-to-multi-point connections. It's like, multi-point GRE or an extension to the GRE implementations. Now we can still have other kind of VPN. We can build something called IPsec VPNs. Now which is going to provide the same thing. We can build a logical point-to-point. Again, it is a point-to-point connection. Again, IPsec VPNs. It works based on point-to-point again. Now the major enhancement in the IPsec VPNs is internet protocol security, which is going to provide some strong encryption algorithms, which is going to ensure that your data is secure. It uses some strong encryption algorithms, which provides some data integrity. Integrity is something ensuring that no one modifies the data. Data confidentiality, sorry. So that's something called data confidentiality, and by using some strong encryption algorithms, it provides that your data is confidential, no one can read that information by using some strong encryption algorithms. And also it provides something called data integrity, where it will ensure that no one modify the information. So it uses some strong hashing algorithms where you send the information, if someone modifies, it will identify the hashing algorithm on the opposite side, and if that does not match, if someone modifies, it will not match, so it will automatically drop. It provides data integrity, as well as it provides some authentication methods where you can identify the remote peer by using some passwords we can configure some kind of passwords on both the sides, which will ensure that if the password matches on both the sides, then only it's going to establish the VPN. Now these are the three different kinds of implementations which can be used in today's networks. Now in today's networks, we don't use GRE. That's something not much used in today's networks. And VPN, IPsec VPNs, they just provide only virtual point-to-point connections. Now probably most commonly in today's network we use something called DMVPN, and over that we can build IPsec as well. Because DMVPN, the major advantage is we can have point to multi-point connections, dynamic multi-point connections. That's something very good, but there is no security. So to provide the security, we can still have IPsec implemented over DMVPN. Now this is something what you will see more in detail on when you go with some CCNA security, CCNP security kind of stuff, or if you're going with some CCI routing switching kind of topics. In the new version it also covers this, but in CCNA we just provide some introduction on these technologies. Now these are all come under this category, and then we have two types of VPNs again. In fact, we have many types of VPNs. Like if you get into some advanced topics, a site-to-site VPN is a place where we are connecting our branch offices to the head office, or from branch office to branch office over internet, and there is a virtual connection VPN tunnel established between them. Whereas in case of remote access VPN, we are going to provide the remote users, maybe he's sitting in a conference center, or maybe sitting out of station, he's sitting in some hotel room, or maybe he's moving around, but he's connecting to internet, and from the internet he can connect to the VPN server, some device over there which will authenticate this user, and he can access the resources in the LAN as if he is sitting in the LAN via remotely. And this user is going to install some VPN client software, and he can access the resources as if he is sitting in the LAN. That's what we call as remote access VPN, where the users will get an access to the remote user networks by sitting anywhere, probably sitting in the home. You can access the resources. Now these are two typical kind of VPNs which we use, and to provide security, VPNs uses some IPsec protocols which provide some data confidentiality, data integrity, as well as it provides some authentication of the source.